Dear students, in this lecture, we'll discuss about movement of free electrons and holes in a semiconductor material. This is very important part. This is very important concept to be discussed so that we can easily understand the flow of current in a semiconductor material, and we can also understand the difference between movement of free electrons and movement of holes in a semiconductor material. So we can make it easy with the help of some example. Suppose they in a row some students A, B, C and D are sitting, and then at left side there is vacant space, and somehow if this space is comfortable, then other these places, if this space is comfortable, then other these places, then definitely this A will like to shift this comfortable position. Now there will be A, so this position will be vacant, and then B, and then C, and then D. At other moment, B can shift to this position in view that if A could leave this place, then B can get this comfortable place. In that situation, suppose A is at this position will be filled by B, and now this position will be vacant. In similar manner, A, B, C, and now this position can be vacant because C is shifted to this position. And similarly, A, B, C, D, and this leftmost comfortable position is filled, and all are shifted towards left side. So in this manner we can see the vacancy which was at leftmost place, is now somehow at rightmost place. So in this process, in the every moment, suppose in this example, A is shifted from its place to leftmost place by breaking and making its bond, or leaving and getting this place. There are two processes are followed: leaving and getting this place. So in this movement, we can say a vacant position is shifted from left to right, or we can say A is shifted from right to left. Both statements shows same information. So similarly, if in an atom, in a material, there is some vacancy, that means there is a hole, so bonded electron can move from its position to vacancy, and in that manner vacancy will be shifted from left to right position, and the bonded electron will be shifted from its position to vacant position. For example, suppose we have a silicon material, and silicon material is bond between different silicon atoms. I'm trying to make it easier to understand the flow of hole in a semiconductor material. Suppose there is some vacancy at this position, and due to some any reason, if this electron is getting more stabilized position at this position, so it will leave its position and will shift towards this position. So in this situation, a vacancy will be created at this position and this will be filled. In this process, the electron at this position is breaking its bond from this position and making its bond at this position. So in movement of hole from this place to this place, a bonded electron is changing its position, and in this process this bonded electron is breaking its bond and then making its bond. Similarly, if this electron is doing this behavior, so it will break its bond from here and make its bond at this position. So the hole which was available at this position is now shifted to this position, and in this manner hole is shifted from this to this, or we can say electrons are shifted from this position to this position. The important point to be noted is here, is that bonded electrons are moving. A bonded electron which are available here shifted its place to this position, and bonded electron which was available at this position shifted its position to this place. So in movement of hole, bonded electron moves, and in that movement bonded electrons follow breaking and then making of bond. So definitely in the movement of hole, two processes are required: breaking and making of bond of bonded electron. So this process will be slower. That's why we call that movement of hole is slower than movement of free electron, and this is represented by a property mobility. Movement plus ability. Movement plus ability. Mobility. So parameter mobility represents ability of any charged particle to move. So definitely by this process we can explain that movement of hole is slower than movement of free electron, or we can say mobility of free holes is lower than mobility of free electron, because free electron is free from every type of bonding. It can move easily on the application of some voltage source. So definitely I think it is clear that how holes move in a semiconductor material by breaking and making of bonded electrons, and free electron move in a semiconductor material because it is free from every type of bonds. So that means presence of hole or presence of free electron in a semiconductor material can be helpful to conduct current through semiconductor material. But definitely it is also clear that the movement of current or flow of current due to a hole will be lower than definitely flow of current due to free electrons. When in a semiconductor material number of holes available are larger, then this type of semiconductor materials are called p-type semiconductor material. And when in a semiconductor material large number of free electrons are available, then that type of semiconductor materials are called n-type semiconductor material. So the target of this lecture was just to explain the movement of holes and free electrons. In next lecture we will discuss about types of semiconductor material, means intrinsic and extrinsic, then p-type, n-type, and then also the formation of p-n junction. That's all for this lecture. Thank you.